And so as was introduced before, I'm responsible for data center operation at Statistics Indonesia headquarter office since 2017 after coming back from my master study in the United States. So it's been almost 4 years, 5 years in the headquarters managing the data center, mostly for the data analytic system, platforms, and servers. So like all those uh, system and servers that were used by our data scientists. Mostly it's prepared by my team. Yeah, not only me, but mostly me. And so I like moving around between places every about 5 years or so. I don't know, maybe I will do something else in the next several years. I plan to do my PhD or something else. We don't know yet. So before uh, going to the United States, I was in the BPS Regency branch office in Sulawesi Selatan. Yeah, that's another island from Jakarta, far, far away. Okay, probably that's enough intro. So today, on the first day of the third part of the data engineer stream, we will learn a little bit about every bits and pieces of the Hadoop, or the in general it's the big data processing tools, and we will learn a little bit deeper about the main concept, which is the HDFS and my previous concept, and then we'll look at the several details on the ecosystem architecture and distribution option, and about procurement option, purchasing hardware, software, and some security layer, and some installation steps. And at last, we'll check your hands-on setup. Okay, first we'll look at several companies that are powered by Hadoop. Um, so this is some 3 examples. So they have so many nodes, thousands of computers connected as Hadoop cluster. Yeah, BPS only has 9 nodes, three. That's the one for dedicated for Hadoop. We also have general purpose servers serving other purpose, like our email system, our online storage system, and other things. So here we also see that Facebook also has a lot of Oh, they don't mention the nodes here. It's just the storage very big because they store images, photos, videos, always growing. So they always purchase new servers every day, adding new nodes. And even for Google, they purchase specialist hardware tailored to their needs. So they don't purchase hardware from commonplace. Okay, so this is just for the beginning. It's proof that Hadoop is so powerful to run the core processing system at these big companies. So like Spotify, they store a lot of music. Okay, so how did Hadoop happen? So there's two people, mostly the lead is the dog cutting. So they develop some project, but they implemented a free version of Google published paper. So actually it's Google paper that inspired them, but their implementation is not exactly the same like the one implemented in Google's internal system. So Google did not publish their internal system source code, and some people say that the implementation at Google internal system is far better than what we have in the open source world, like the Hadoop that we use, that other people outside Google use. But it's similar in the concept because we follow the description that is described in the paper that published by Google. So if you are interested in reading deeper about that paper, you can ask me. You can search on Google. Don't search Google inside Google. Google will explode. That's a joke. And so also Google introduced paper that introduced the MapReduce concept. And then they also imitate the concept in that paper to develop a free version of that MapReduce concept. And then as an open source movement, other people start contributing, and even some people from Google, of course, but still, of course, it's still different from the one implemented inside Google. So this is some of the paper that inspire our big data processing history. And so every big IT company like Facebook and Amazon, Yahoo, they develop different version of their own big data processing tools because they have different needs, because they have different nature of data. So they develop something that's tailored to their data processing needs. So like Amazon, they want something very fast to do key value store, matching the their product items that they sell on their site and the catalog. And then they develop also recommendation system. And for Facebook, they want something that very fast in processing the graph storage system, because it's a social media and they map users as graph. And so you can search these papers if you want to dig deeper, but that's just the gist. So this is a typical implementation architecture of when you want to use Hadoop. Usually nowadays it's called a data lake. So you just put in every data source you have, structured, unstructured, big data sources. You just put everything there on the landing zone. So you will divide the data lake into 3 zones. You just create schema on when you need it. So you don't need to prepare schema when you first ingested the data. And then you can keep some of the data that's ready for consume by reporting system, dashboard system, and the analytics system. And also the data lake will provide you with a faster processing system for analytics. So it's not recommended for transaction system, like collection system. We do it outside the Hadoop. So this is for single source of truth, if we call it at the BPS. So the final data from every sources, we put everything there. So next, why is it so popular? Because it's free. Well, you can also get a paid support for installation and troubleshooting, and some give license for the hardware or the certifying that it will work correctly. And so it's cost effective. You can just use commodity hardware that you can buy anywhere, and or you can use the cloud. And also you can start small and you can just add nodes later when you need it. It's open source. You can see the source code, you can contribute to the source code. And ease of use. Right now there are so many tutorials online. Okay, and the main concept, the most important thing is HDFS, the Hadoop Distributed File System. So it's how the data stored, and the MapReduce concept for the parallel processing. So mainly it's parallel processing. which is actually hard because there are a lot of things to keep track when you do combine multiple computers to do something. There are scheduling problem, divide and conquer problem, and how you combine the end result. So all of those already prepared under the hood by the MapReduce. So you right now nowadays you can just use it. Okay, so if we look a little deeper in the HDFS, it's basically divide the chunks of data into the data nodes you have, and it can be replicated. So in replication, you store a copy of the same data in different data nodes so that if one data node is down, you still have other copies of that data in the other nodes, and it's encrypted. But of course, this is good for big data. So if your data is small, you better not use this because it will need some overhead to divide the data, divide the task, divide the processing, and then combine back the result. That will be slower in small data. So of course, when your data is big enough, that's when you should start using this. Okay, so this is a simple illustration of MapReduce parallel processing. So the ingredients are the chunks of data, the chef are the data nodes, and recipe is the program that you want to run. So the map process will divide the ingredients to different computers. So like dividing the ingredients to different chef, and they all cooking at the same time. So the end result of the cooking is faster. And after the mapping task, everyone is working. And at the reduce step, you just combine the result to produce the final outcome of the cooking. So that's the gist. We can look into the more details. You see, this is some part of the original slide from Google for the MapReduce concept. This is the second version of the MapReduce. I think the one that started blowing up and make it become popular. So do we really need to do distributed computing? Yes. So the example here is from Google big data processing use case because they are crawling web pages, 20 billion web pages on Earth. For example, we assume each web page is 20 kilobytes, we get 100 terabytes. Google doesn't have 4 months to read the web, so they need to do that faster. So there are some problem with programming work in parallel computing, communication and coordination between nodes. Sometimes one machine or more fails, so we need something to make it uh, work. And there's a second bad news. You have to do this for every problem. Hmm. Hmm. So they make this apparatus ready to use. They introduce that as simple programming model. But then in this first stage, you have to write codes to run MapReduce jobs. There you can mostly use Java or Scala programming. But nowadays, we can just use normal SQL because there's an abstraction layer that we will explain later. So MapReduce is a runtime library. It handles all of this, like the automatic parallelization, load balancing, machine failures. It's handled, and we don't have to worry about that. We can just use it to solve our problem. So these are typical problem that can be solved by MapReduce concept. So if your problem is far from this, maybe you need something else, not MapReduce. So this is the usual pattern of MapReduce. You extract something from each record, and in the reduce part, you do some aggregation or summarization. Okay. So this is a little bit more details. So inside Google, a reasonable number of mappers are 200,000. So of course, Google also have thousands of nodes and adding nodes every day. And so Google has proven that this is working well, very robust. Sometimes once they lost 1,600 out of 1,800 machines, but the work still completed. So it can recover from failure. So something that completed or in progress, it will be executed. Even master failure, there is a checkpoint state that's replicated in the file system, and the new master can continue. And so this is where you need to be careful. But this is the early stage of MapReduce. before we see Hive and other things that can run so in Hive right now you can just write normal SQL and it will automatically translate into MapReduce jobs. So you can worry less about MapReduce. Any questions so far? If no, we can probably continue. So the physical architecture is just a bunch of computers. You can have several master depending how many workers you have. So you can start with one or better with two master and probably three or four workers or data nodes. So the master is the one that will orchestrate everything. They will divide and conquer the jobs and they will collect the result and ask them to combine the result. So the slaves or the data nodes, they store the data and they process the data. So Hadoop use local storage. So the storage is in every data node. So it will be processed locally in the data nodes for each map task. So this is the architecture if we view the data flow. Here the master node is called name node and you can have secondary name node. It will store the metadata. So each data node will only store the individual data blocks and it's encrypted there and encrypted in transit. So when client asks for processing something, it will take the metadata from the data node and also the data node will tell the system where to fetch the data in which data node and you will get the result. So the secondary name node is for the backup. It will act as name node if the name node fails and continue from the last state. Also from different overview, the master node and the purpose of master node is not as the name node only, it's also as the resource manager. It will divide and the task to every node to the node manager in every node. So that's the other job of the master node, scheduling, resource management. So if you have multiple master node, you can divide the master tasks between nodes. We can explain later with sample of service layout. And so finally, to support everything that's an ecosystem of Hadoop, there are many components, each with its different purpose that work together. So it's hard to keep track of this by yourself. So there we need distribution. So like version 1 of something only work with version 2 of some other components. It will be crazy to keep track of that by yourself. So there are Hadoop distribution that will do that for you. They tested the compatibility of the version of each component, and so you can use everything ready. So there's Zookeeper to monitor, coordinate everything in the zoo. So it's like zoo because they like using animals name and symbols here. So let's see next. This is an example of components from Hortonworks. So between distribution, these components is slightly different, but the general gist is the same. They have HDFS at the bottom, yarn on top of HDFS. So yarn is the cluster management for Hadoop. And then on top of that, you will have other processing tools that you will interface with them directly. So the top layer is the one that you will directly interacting with. That security component, other things. Okay, so this is the overview that simpler. So on the top layer, that's the one that you will interact with. For example, an SQL interface like Apache Hive. So you can just write SQL query like in Microsoft SQL Server, and Hadoop will automatically translate that into my previous job. So this translation process will take a few seconds overhead before it will be run in the Hadoop cluster as my previous job. You will just get the result. You don't need to worry about the bits and pieces of MapReduce like before. And then there's another improvement too that replaced the original MapReduce. It's the MapReduce library in the processing framework layer. So they implement something faster like Apache Spark that run in memory. So of course, memory is faster than disk, 100 times faster, but you will need more memory. Yeah, memory is more expensive, of course. You need more money to use that. You need more RAM. Also test, that is also something that they claim better than MapReduce. It's from Hortonworks, so you will not see tests in Hadoop distribution other than Hortonworks. In Cloudera, they have Impala. That's equivalent to test. Okay, if there's no question, the next part about security layer will be explained by Hanif. I will stop share.
Hello, good morning, everyone. Hello, hello.
Yes, we can hear you.
Okay, I'm sorry there is some technical difficulties in this. Okay, I will continue the material from this session. Wait a minute. Okay, this is the last slide, the slide of Mr. Sinung. Okay, okay. Firstly, before I continue the security layer of Hadoop, I will reintroduce myself. My name is Muhammad Hanifayu Ananto. In this session, I will continue the material about security of Hadoop. As far as we know, security is one of some critical part of a system or application that we must ensure during the production. In Hadoop, there are four main security points of Hadoop. The first one is authentication. Second one is authorization, auditing, and data protection. Authentication is generally about oh wait really eh wait a minute. Okay. First one is authentication. Is it about who am I or prove it? Is it about to identification who is the person that access the resource of Hadoop? And the second one is the authorization. Is it about what can I do? What can I do to the Hadoop resource? And then the third one is the auditing. This is about what did I do? So the system can audit what have we done to the Hadoop resource. And for the last one is about data protection. This is about how can I encrypt the data at rest and over the wire. So the data will be ensured that is safe when the data is safe, is at rest. Is about data stored in the HDFS and how the data is safe when transmitted from storage to the client. Okay, next. The first one is about Hadoop security authentication. Okay, for general, there are two main authentication in Hadoop security. The first one is the overall cluster security, and the second one is the perimeter security. The first one, the overall security, can be using the Kerberos. Yes, the Kerberos is the global-wide computer security that developed by MIT, Massachusetts Institute of Technology. And in Hadoop, we can use this security system that implemented to all nodes. And for general, we know the Kerberos have term of KDC, Kerberos, I'm sorry, K distributed center is the heart of Kerberos. So before we can secure the Hadoop, we must install the Kerberos, and in the Kerberos, there is the single big, there is a KDC. The KDC is consists of three components. The first one is the database in this left, and then there is the authentic. Oh, I'm sorry. And the second one is authentication server, and the third one is the ticket granting server. Is the also that's all the three main component of KDC. And in KDC, there is a general flow that when we can authenticate to Hadoop resource, the flow is shown in the slide. The first one, the user of Hadoop is do commit to authentication server, and then the authentication server will validate if the user is true, is validated, is correct. The authentication server will grant the user with TGT, ticket granting ticket, and then the user will execute the Hadoop command, and the Hadoop command will send to, and the Hadoop command will communicate to ticket granting server, or we can say TGS. When Hadoop command communicate with TGS, it will bring the TGT2, and TGS will validate the TGT and the request of Hadoop command, and if it correct, the TGS will issue the service ticket and the session key. What is service ticket and session key? The session key is used to validate the time that user of Hadoop will use the Hadoop. And the service ticket is used to communicate with Hadoop resource. And the Hadoop resource will validate the service ticket. And then, and if it's true that the user is granted or authorized to access Hadoop, the Hadoop resource will be respond it, and the response will be shown into the user. So it can be implemented the Kerberos for such as SDFS or Hive or HBase or the Yarn or MapReduce or any service of Hadoop. And then we move to the second one of authentication of Hadoop. That is a perimeter security. Okay, the perimeter security in Hadoop is supported by Knox. What is Knox? Apache Knox is an application gateway for interacting with the REST APIs and UIs of Apache Hadoop deployments. So is it about a single gateway that user can access the Hadoop resource without communicates its service API. In this slide, we can see there are three mainly area that Knox cover. The first one is Knox cover the proxying service. Second one is Knox authentication service. And the last one is client DSL or SDK services. About the proxying, okay, let me tell you about the proxying service. The proxying service is all about HTTP proxying service. It's from UIs, WebSockets, REST APIs, or maybe the SQL or the databases. And it's cover all the service of Hadoop from Ambari, Yarn, Ranger, Zeppelin, until Hive, HBase, and many more. And the second one is about authentication service. It's cover the Knox SSO or the token, and then the authentication and federation providers. So the Knox is can extended or we can call collaborated with enterprise identity system. It can be the LDAP or Active Directory or HAML, and Knox is support the SPNego or Web SSO and many more. And for the last one, the Knox client DSL or SDK service is cover the Groovy based DSL or Knox cell. Is it about the DSL and SDK? Okay. Maybe we want to know what the advantage of Knox. The Knox is there are 4 advantages of Knox. The first one is simplifies access. It extends Hadoop REST HTTP service by encapsulating Kerberos within the cluster. And the second one is enhanced security. So it's not revealing network details and providing SSL out of the box. And the third one advantage is centralized control. So the REST API security is centrally routing requests to multiple Hadoop cluster. So the Knox is the routing, the root have role of routing. And the last one is enterprise integration. Because I have explained about the in previous slide that Knox can collaborate with any enterprise identity. So we have big advantage. And for the next thing is the authentication flow using Knox. So this is a good explanation about how we develop Knox to Hadoop resource. In this picture, the client is access the Apache Knox, and the Apache Knox will identify the user by using maybe Kerberos or LDAP or Active Directory or any identity, enterprise identity. And if the user is validated, the user will be the user can use any API service, any API from any Hadoop service, or the user can access some UI from Hadoop, such as name node UI, job history UI, yarn UI, and many more. So before I continue the authentication, I'm sorry. Before I continue the Hadoop security for the second component, the authentication is optional. Is it? It may become optional choice to deploy Kerberos, but if we want to deploy the Hadoop as production stage, the authentication is what is it? It's about the must we have do. But if we deploy the Hadoop as development or about research area, research development, the the security is not must do or become is not mandatory, or we can call is optional. So if we want to deploy Hadoop as production, the security is mandatory. We must use the Kerberos, and the Knox is become we can deploy it, or we can use it. The Knox is optional. It depend on the requirement, but the Kerberos is must be done if the Hadoop is production. Okay. Next is the second major Hadoop security, the authorization. This is authorization is the main part of Hadoop security that will manage what the user can do to Hadoop resource, such as can the user access the SDFS file, or the user just can do query to Hive table but not the file, or the user just can see the name node UI or any others rule any others authorization. In this slide, the Hadoop can implement the authorization by using Apache Ranger. In this diagram, the Ranger is maintain its authorization from its base, the authorization of Hive Server 2, SDFS, Tom, Knox, Solar, Yarn, until Kafka. Almost all service, but not all service of Hadoop. And the Ranger is using MySQL, Oracle DB, and SDFS for the Ranger audit server. And yes, and next one is this is the general UI of Apache Ranger. There are three features from access manager. The first one is access manager, the second one is audit, and the third one is security zone. Okay, the authorization is related to the first feature, the access manager. In the access manager, we can set its service policy. We can see in here the HDFS service. There is the test cluster Hadoop policy. For Hive, there is test cluster Hive policy, and etc. Next one is, what about the user or group synchronization in Ranger? Why must synchronization in Ranger must be done? Because the Ranger must know the user that use the Hadoop resource. So the Ranger of course have the data, its own database. So we must to synchronize the user from external and into the Ranger's database. It's called synchronize. The process is called Ranger user sync. The Ranger user sync is import the data from LDAP or maybe from Kerberos, or using or can use Active Directory or free IPA. But if we don't use, okay, it's enough. And it is the general view of how Ranger we can set the policy for its service. What is it? It's look like the how we can save how we can configure. I'm sorry. This is the sample of how we can set Hive policy in Ranger. We can set the policy name such as customer details tables policy, and then we can define the Hive database name XA demo, and then we can define the tables. We can define one by one, or we can define all by give the stars character. And then if we want to specify so detail about Hive column, we can specify it in this text area. Maybe about the phone number, the plan, or the date. And then for the all objects in upper part, we must set the permission for each user or the group. In this sample, we set the user of Mal and Inara and the group of marketing just can select for the table customer details at column phone number, plan, and date. They can update it, they can create it, or they can drop it in any other operation. They just can do select operation. This is this is a sample of authorization for Hadoop for Hive services. Okay, let me continue for the third component of Hadoop security. That is the auditing. Before I explain the Ranger, for general, each service of Hadoop is do the auditing process. So the HDFS do auditing, the Hive do auditing too. Of course, the HBase and MapReduce or Yarn do the auditing. Why all of services do auditing? Because they because it will provide the information it's access from its services. In simple is auditing give information for administrator to monitoring its service. So Why there is auditing in Ranger? Because uh, because I say why Ranger have auditing feature in here? Because it will simplify the view and simplify them to manage all of auditing its service, all auditing auditing Hadoop services. In this sample, audit feature show us the access, admin, login session, the plugins, plugin status, and user synchronize. From auditing access, we can see all the access history that got into Hadoop area. It looks like in this. There is user atlas that access resource atlas, and the access type is get, and the result is allowed. It means user atlas is allowed to access the resource atlas, and we can see the client IP in here. There we can set the filter in upper part in the search input searching field. Is a powerful auditing mechanism in Ranger. And then for the last one is the data protection. Data, okay. Hadoop implement transparent encryption to protect its data. The data that is to be read from and written to the special SDFS directory is encrypted and decrypted transparently without requiring any change to the user application code. So the Hadoop cannot read, but but only user that can read because the user is the role that encrypt and decrypt. And then it's called end-to-end encryption. Only client will encrypt or decrypt the data. And then the Hadoop will never store or have access to unencrypted data or unencrypted data encryption case. So it means it will satisfy at-rest encryption and in-transit encryption. Yes, there are two kinds of encryption in Hadoop. The first one is the at-rest, and the second one is in transit. What is at-rest encryption and in-transit encryption? It is about the first one is encryption of the data when data is on persistent media, such as this. It means the encryption when data is stored in the SDFS. And we can use the encryption zone with Ranger KMS. So the Ranger have another feature, it's called Ranger KMS. It will encrypt the data into special directory. And when the user want to read it from the special directory, the user must decrypt it first. And then for your information, the at-rest encryption is not applied to the overall directory. It means the user can specify which directory is special for encryption. So another directory can be not encrypted. But if we plan to encrypt all the data or we will encrypt all the directories, it's up to you. But but the encryption is not, in the basic is, the encryption is not mandatory, it's just optional. If you want to encrypt some directory, you can do as you wish. And then for the second one is in transit encryption. The encryption of data when data is traveling over the network by using HTTPS protocol. It means if we want to encrypt the data in transit, we must use HTTPS. But if we don't want, we just use the simple one, HTTP protocol. Just that it's. So we have Ranger KMS and we have HTTPS protocol for data protection in Hadoop. Yeah, this one is the resume for Hadoop security. This is how the security of Hadoop is implemented. From the inner one, there is the OS security. For the second layer, you see in the slide there is the authorization, and the outer part is the authentication. We use Kerberos, and for green layer, the outer ring, we have the perimeter level security, such as the firewalls, or we can use, or we can add, added or extended it by Knox. And don't forget the main area is the data protection, where is it's implemented by core Hadoop. You can use the Ranger KMS and the HTTPS. And then I will continue. Uh, Wait a minute. Is there any question about the Hadoop security? Okay, if there is no question, I will continue the Hadoop distribution in this part, in this session. Uh, there are two options of Hadoop distribution. The first one is on-premise and the second one is on cloud. The on-premise option, there are Cloudera, SDP, Hortonworks Data Platform, and the last one is the MapR. For the on-cloud option, there are Azure SD Insight, and the second one is Google Dataproc. For the third one is Amazon EMR, or abbreviation from Elastic MapReduce. And for the next one, we must to know the consideration or points of consideration before we choose of Hadoop distribution. The first one is the capacity planning. Which one we will choose, on-premise or on cloud? And then the second one is architecture planning. And the next one is next thing about the software planning. It's about we will we use the free or open source software, or we use the paid support. I'm sorry. Software planning is about use the free or open source, or we use the paid version. And then if we choose the paid distribution, the paid Hadoop distribution, we must think about the option, the purchase option, the procurement process, and then both of them, both of the free or the paid, or the premise or the cloud, we must consider the installation planning, and then we must consider too the business process onboarding. Okay, maybe my material is enough. And is there any ideas or any question about two materials of me about the Hadoop security or the choosing Hadoop distribution? Is there any question or ideas that us know? Okay, sorry. Maybe if there is no question, uh, maybe Mr. Sino, my friend, can continue the materials for the installation of Ambari.
Okay, thank you, Hanif, for the security layers, for explaining the security layers of Hadoop and some option of the purchasing. So before continuing, if the host can accept my other Zoom connection from the laptop.
Recording in progress.
Okay, thank you. So Hanif has explained about the security layers and the distribution options. So the last part was the how we plan about the hardware and software before we continue talking about the installation. So first you need to do some capacity planning, be it on premise or on cloud. So you can start small by as small as one nodes, and you probably want to plan how it will be connected to your other systems that are already existing, and how's your budget, and you can check the price if you want to purchase some support from Hadoop distribution. And of course, the between on-premise and on cloud, you will choose how you will manage that by yourself. And another consideration if you have some sensitive data that you don't want to put on the cloud, maybe you want to stick with having on-premise installation, and then you need to align that with how you will adjust your business process when you do have some big data processing tools. Okay. So for Hortonworks, this is an example for Hortonworks that we use. So installation and cluster management will be done through a component that is called Apache Ambari. In short, we just call it Ambari. So it's basically we interact with on a website. So it's a web-based software, but it's also a database. You can use MySQL or other, but the commonly used is MySQL. And then there will be Embry agent on every node. So this agent will be communicating with the Embry server. And so you need to put agent in each node that will report and communicate with Ambari about the status of the services. Okay, so when you have them installed, you can manage everything from the Ambari web interface. But of course, you will need to jump to the SSH and command line if something goes wrong. So this is a sample of BPS development cluster. We have 6 nodes, 3 master nodes, and 3 data nodes. 128 gigabytes of RAM, but about 3 gigabytes is used by the operating system. and 32 CPU cores each. And the Hortonworks version 3.1.5. So this is where you monitor the services, the components, like we explained before in the ecosystem. There are many services. And this is the one we have in production. We have 9 nodes. The Ambari we show you before was our development servers. So this one has bigger specification. So you can plan something like this or bigger or smaller. It depends on your needs and your budget. So for the Hadoop nodes, you should have local disk or big disk on each node. And for other tools like your BI tools like Power BI or as dashboard system, your other dashboard system, you can have shared storage. So it's a storage area that will be shared between multiple servers. So the servers itself doesn't have storage on it. So for local processing, for faster local processing, Hadoop use local storage in its nodes. So that was the hardware. You have prepared them, and also here we skip the operating system installation. So this is what you prepare after you have it installed with the operating system. You put the IP address on it. So the operating system option better with Linux Red Hat base like CentOS, the free version of Red Hat. Well, if you have budget, you can have Red Hat Enterprise Linux. So these are the simplified version of the installation where you prepare the node. So there's Hortonworks public tools to set up the passwordless SSH. This is how the nodes will communicate between each other. So you need to set up this first and distribute the key. So that way the nodes will be able to securely communicate with each other, like distributing their MapReduce task and sending some data or some result between each nodes. So with this setup, they will do that seamlessly under the hood. You don't need to worry about that anymore. Okay, once you did that, this is an example from, because we have a license from IBM, so we got the Hortonworks that is licensed through IBM. So apparently IBM has an agreement with Hortonworks before Cloudera and Hortonworks has a merger. So we download the binary from IBM. So this binary probably has some proprietary code from IBM or Hortonworks. And so in this second stage, we need to prepare the packages to set up local repository. So this is another thing that you need to know about Linux system is they usually have a repository to store their package files that where you will use package management tools to install software. So when you install a package, it will call to the repository to get the dependency software and install them alongside with the actual software. So it's a principle in the Linux system that we use shared libraries between software so that it will always stay lean. So there's no double library that will be used between software like the clutters we see on Windows. So we prepare a web-based repository in the local system. So the detail is not here. If you need the details, I can provide you later. So then you install the Ambari server, also install the Ambari agent on each host later, but you will need to prepare the Ambari database and Ambari server first, and the local repository packages for the Hortonworks and Hortonworks utility or HDB utils. And you should prepare the database credential for the services. So some services require its own database credential. Okay, then this is the last stage before we see the Ambari install wizard. Okay, so here you will decide how you deploy your service layout. So like, let's see an example. So for example, here we have several nodes. Here 3 master nodes and about 6 worker nodes or data nodes. So we distribute component services to this master node. So let's assume this is the first master node, this column. So you put some services there, like the Ambari. So, but we put other services on the other nodes like MapReduce server, Yarn server. We put it on the second master node. and all slave component we distribute on the data nodes. So we can distribute the load between the master nodes. So this is an example how you spread the services layout if you plan to have multiple master nodes. Okay, after all of those steps that you do at the command lines, you will have this Ambari install wizard. Welcome to Apache Ambari. And you can create cluster. You can have multiple cluster, and if, for example, if you want to have a backup data center, or you have multiple cluster for different purpose like development cluster and production cluster, where you test things on the development cluster and do only final data on the production cluster, for example. And here you can manage the users who you will give access to the Ambari server. Okay, from here you can click the launch install wizard. Then it will ask for the repository location that we defined before in the command line. So this is where you define the version and the local repository. So this way with local repository, another advantage is that you can isolate your Hadoop cluster from your other system. So tampering with the Hadoop cluster will be harder. That's why you have a local repository around the Hadoop cluster. And also you can do this without being connected to the internet. Okay. And you can have multiple version. So for example, here our repository uses Red Hat, and that's the URL to the repository. So this repository will store all the packages and the libraries needed to install the Hadoop cluster system. Okay, next in the wizard is you register all the nodes. So you use the domain names and you provide the key. So if it can connect to its node successfully, so if some of this fails, you need to go back to the command line steps in the SSH. So until it will be registered successfully here. So we are on the confirming host in the third step from the, you can see there's 10 steps here in the wizard. And next, So there are some steps here that has been skipped, like choosing services. So we just choose the services like the service layout we see before. We assign the masters, we assign slaves and clients. Then we set the credential for each services and databases, and you set the directories for saving the Hadoop data. Uh, so you have a lot of disks, multiple disks in the Hadoop data node. So it's better that you just leave them alone. You just define the location to those disks in this directories. Then you set all the accounts. So you probably should keep notes of this, and should be a secure password with combination of probably lowercase, uppercase, symbols, numbers, those things. You can have some formula of your own password to make it easy to keep track. And the Kerberos security should be done later if it's on a production server. Okay, when you're done, it will show you a summary of the services, where you put them. You can save, generate a blueprint, so you can follow the same service layout later if you want to reinstall or you want to install on another cluster. Then when you're ready, you can click deploy. So there will be status progress for each nodes. Okay, there's some warnings. Only one node successful here. So actually turn out those security layers. You cannot install that in the beginning. You should exclude that from the installation first, and you should install them later. So that way the installation was successful, and it will be starting services. So when it's successfully installed, you can see the cluster disk usage, memory usage, and other things from this summary. You can see which services are up and down. You can start and stop services. You can also check on the host, which host is connected, or maybe some host is down. So of course there's a common pattern here. Green means it's running well. Yellow means a warning. Red, there's something wrong. And after that, you can set up Kerberos security layers. So you can run the install wizard again after that to add some other services. So for example, here we have IBM Big SQL. This is a proprietary component from IBM that to enable you to query to do SQL query between directly combined between Hadoop and other platform like Microsoft SQL. Okay, I think that's the material we have today. So probably we can discuss on if your hands-on setup, if you have difficulties preparing or you have any question. Probably we can continue with checking your hands-on if you're ready. So for now, I'm returning the floor to the host. Thank you.
Thank you, Pak Amin. Okay, so please kindly check on the document that's sent by Pak Sueka Putra on the reminder for this workshop. So it's contained the list of the software that need to be installed for this workshop. So is there any problem on your computer when you install the software? If you have any problem, maybe you can try to share your screen so BPS Indonesia can try to solve the problem. The software is VirtualBox. It's quite big, around 20 gigabyte ya Pak Amin ya, 20.5 gigabyte. Okay, so have you download and install the application? If you already download and having problem during the installation, please let us know so BPS Indonesia maybe can try to solve the issue. If you don't have any problem during the installation, so maybe we can take a break for 15 minutes, yeah, for 15 minutes. So we can end back again in 10:20. Thank you. Okay. Good day, everyone. Sorry, it's a little bit late. I think we can start again for the next agenda. For the next agenda, who will be present from BPS? Is it Ibu Isnaini? Or still Pak Amin?
Yes,
Okay, so it's
I
still Pak Amin, yeah?
yes, I can continue with explaining the hands-on before we do the hands-on tomorrow.
Okay. Okay, so we can start. Continue the training. The floor is yours, Pak Amin. Thank you.
Thank you. Okay, hello again, everyone. So our materials actually running out. So we actually prepared the hands-on for tomorrow. So, but we can start the explanation right now. So you have the idea what we are going to do the hands-on. Let me share the screen. Okay. So this is actually we prepare this for tomorrow, but since we run out of the materials, we can start talking about the hands-on for tomorrow. So in this hands-on, we'll check the setup. We'll say Ambari in action, HDFS, and then we will try to put some data to the Hadoop. We'll do some query on Hadoop. Okay, so the hands-on setup is you need to install VirtualBox. So the VirtualBox is a software that will emulate a virtual machine. So you can run the single node Hadoop that is ready. And here we use Hortonworks image, which is now archived on the Cloudera website because Cloudera and Hortonworks is on a merger. They are a single company entity now. So the recommended setup is 16 gigabytes memory. 10 gigabytes will be allocated to the Hadoop sandbox. So this sandbox is basically a virtual machine file with the 20 gigabytes download size. And then it will be extracted also probably about 20 gigabytes. So you need to have at least 50 gigabytes disk space for the image and the extracted image. Okay. So you just click next on when you're installing VirtualBox, and then you will import the sandbox image that was downloaded, and you can just follow the default option. You will see something like this when you try to open the image. And you can click import and wait. So it will take some time. So if it's successfully imported, you can start the sandbox. And well, the first one, it will extract the files. It will take some times. So you can wait until it's ready to use. It will show something like this. Then you can try to open your browser. So you will see something like this. So this is basically a single Hadoop node that's ready to use in a single image. Okay. So there's two option. Okay, wait. Excuse me. My Zoom meeting is not responding. Oh, on the laptop. Okay, so if you click advanced, you can see several options: Ambari, Data Analytics Studio, Web Shell Client, and also Zeppelin. Okay, and then you need to change your default password. We use the cell in a box, so it's like a command line terminal in the browser. You should also reset the Ambari admin password. And so this is the Ambari in the sandbox. Only one data node. So this is a single node acting as the master node, both master node, and also acting as the data nodes. So everything in the single node. So this is an example of troubleshooting. If there's a problem, you can access the Ambari server. So you can check the Ambari server status. You can stop and then start it again. So restarting services probably will be common, well, it's not too often, but sometimes you need to do this. So you can do that from Ambari. You can click on the host and start all components. Okay, we'll show you the progress of starting the services. And that's Data Analytics Studio. You can do some query, I think, here. But it's empty. We don't have any data yet in the sandbox. And that's Zeppelin notebooks. You can write queries here too. And then here's a case study or use case with immigration data. So we have immigration data from the Directorate General of Immigration. We have an agreement with them that we can take the data with API service. So we put it on SQL server and then we put it on Hadoop to be analyzed. So this is an example of counting the records of arrival records. So foreigner with a foreign visa coming to Indonesia, there's 300,000 records per month. That is before the pandemic. But after the pandemic, it drops. So only 20,000 records. And then this is a sample comment for importing data from SQL Server to Hadoop. So you should use the IP address of your local Windows machine. We are not using localhost even if your SQL Server is on the localhost, because on the localhost there's also your Hadoop sandbox. And then this is some comments to check the content inside HDFS. So this is HDFS comment. So you can see the parts here. But if you use local operating system comments, you will not be able to see anything because it's encrypted. So you have to use HDFS comment. So there are some other option of HDFS comments like cat, that's to see in the contents of the file. We will do demonstration probably tomorrow. We can do copy files between the local system and HDFS system. We can move files. We can make directory. We can list the files. Okay, and then the next part about the Zeppelin notebooks will be explained by Hanif. Okay, thank you.
Thank you, Pak Amin, for your presentation. So we can continue to the next presentation by Pak Hanif, please. Okay, Pak Hanif, you can start the presentation, please.
Oh, hello.
Yes, we can hear your voice.
Let me see. Where is it? This one. Okay, thank you, Mr. Sinung and moderator. Okay, let me give short explanation about the second day of Hadoop distribution platform for hands-on. For overview, the first one is the checks hands-on setup. Second one is Ambari, and then DFS, ingest and query, and Zeppelin or Hive. Okay, next it has been explained by Mr. Sinung. And then, wait a minute. Okay, I will explain. From this part before next day, second day, it has been done. From this Zeppelin. Okay, we will use Zeppelin for demo for next day, where Zeppelin is analogy to Jupiter. If you have ever do Jupiter, it's same as Zeppelin, but Zeppelin is have more interpreter than Jupiter. Correct me if I'm wrong. And then before we use Zeppelin, we must configure the interpreter first, because there are some interpreter is not the default settings, where one of them is the cell interpreter. It means cell command, where we can do operations such as copy files, or move the files, or execute HDFS, cell command, and many more. This is the sample of how we can set up the cell interpreter. The next is the this is the sample. This is a display where the cell interpreter has been created, and we can configure the value of the cell interpreter, like the timeouts. In here, the parameter is 60,000 milliseconds, or we can say 60 seconds or 1 minute. We can increase or decrease, but for tomorrow, looks like I will suggest you to increase the value, maybe for 5 minutes or 10 minutes, because 1 minute is too short for execute the command. And then this is the slide of how we can create new node in Zeppelin. It's simple as this, where we specify the name of the node and we specify the default of the interpreter. We can choose cell, or we can choose the Hive interpreter, GDBC Hive interpreter, or we can choose Spark interpreter, or we can choose Livy or Python interpreter, and many more. It will be explained more for tomorrow. And then this is the sample of how we use HDFS cell command in Zeppelin. It's about, and then next is sample of scope import command. We can use scope either in command line interface or in this Zeppelin. If we use Zeppelin, we must configure the timeout in this part. Where is it? This one. We must configure the timeout because the default time is 1 minute, where it's not convenient that the command execute under 1 minute. It's not commonly. Its minimum is 3 minutes or 5 minutes. And then after scope, we can do execute Hive command in Zeppelin, which use GDBC interpreter, which especially to Hive. We must define the Hive category in GDBC. If not, the GDBC is interpreted as the default GDBC, where in Zeppelin is translated to Postgre. So we must define the GDBC is Hive. And next is some error in Zeppelin about Hive access control, which I will explain to for tomorrow how we can troubleshoot it with Ranger, because it's about authorization. This is the one of the sample of how we accomplish authorization in Hadoop, where we will use Ranger. This is the Ranger user interface, and I have included the credential. It's still default credential, and this is the sample of how we can set the policy for Zeppelin to access directory. The Hive. How we can set? How we can set the Hive user to access directory of user Zeppelin user. This is the condition, what the permission that we allowed for Hive user. In the screen, we allow the read, write, and execute permission to Hive user. next one is, wait a minute, sending data between local machine and sandbox. So we will try to send data between our local machine, maybe Linux or Windows or Mac, to our sandbox. Looks like Windows. And for the second one is in the bottom part, that is the comment, the sample comment of how we can transfer file from local machine to sandbox. Okay. Astaga, I'm sorry. This is looks like oh, I'm sorry, the last slide must be exchanged with this slide. This is the last slide. And for tomorrow, maybe we can compare between the performance between SQL Server and then with Hive and the performance of Spark, where Spark is in memory execution and the Hive 2 is in memory execution, but different engine with Spark, where Hive use TEZ engine, and for Spark is use Spark engine. In spite of SQL Server, they use its own engine, SQL Server. We will define which is the fastest and which is the efficient. Okay, maybe enough for materials. I will back to the moderator. Thank you so much. Okay.
Oh, sorry, I still muted. Okay, thank you, Pak Hanif, for your presentation. For the IMS, do you have any question, please? If you have no any question, I think we can continue to the next agenda. So, Pak Hanif will be the next presenter. Is it Ibu Anan?
I think that's all we have for today.
Oh, okay. So the presentation is finished already.
The presentation is finished, yes.
Okay, thank you for your presentation from BPS. Today is quiet, but we hope for the tomorrow, since it will be practice session, right? We hope for tomorrow it will be more interactive. Again, thank you for the trainer and participant for continue participating in this workshop. Please don't forget for IMS to install the required software as in the document. If you have any issue, you can solve it tomorrow. So BPS Indonesia can try to solve it. So thank you Pak Hanif and Pak Amin and BPS Indonesia and all participants. See you again tomorrow. And stay safe and